So as you saw in the video clips, convection in the mantle and convection in general is just a heat distribution mechanism where hot, low density materials flow up and cold, high density materials tend to sink. So that happens throughout the Earth's mantle. It also happens in the outer core, which is what generates the Earth's magnetic field. So what we're going to do is kind of sketch out here exactly what's happening in the mantle, and then what the result is on the crust. So we learned that the core of the Earth, and so this is the inner core, the outer core, the mantle, and the crust, just for review, that the outer core and the inner core as well are both incredibly hot. And again, I think the number I used was 12,000 degrees Fahrenheit hot. So material that is in the lower mantle is then, by extension, very hot. And so it becomes low density material and it starts to rise. And then eventually it gets to the crust and there's nowhere left for it to go. So kind of like a hose, if you were to turn it on and let the hose kind of squirt directly upward, eventually it'll start to splay out in all directions. So what happens is when it hits the crust, it turns. And this is all happening in the solid state and very slowly. So what happens is over time it'll cool off. And when it cools off, that high density material, or that high temperature, low density material will start to cool off and become higher density material. So when it cools off, it gets heavier and it starts to sink, and it sinks back down through the mantle until it hits the core again, at which point it starts to heat up. And so the process continues. And so this doesn't just happen in one spot in the mantle, it actually happens throughout the mantle. So I'm going to do a quick sketch here, kind of illustrating that cool things sink and they get heated back up and then they start to rise again. So you'll have regions in the mantle of material sinking and other regions where material is rising, where the material is hotter. And so these are called convection cells. Convection cells are found throughout the mantle. There's actually a lot of research as to why some areas seem to have regions of regular rising, how fast material is moving, whether there's one big set of convection cells, which is what I'm sketching out here, or whether there's sort of an upper and a lower set of convection cells in the mantle, what causes them to stay stationary in some spots and then move in others. So anyway, that's a big area of research in geology. So here we have mantle convection. So if you notice, the crust is incredibly thin relative to the mantle. If you think about like a hard-boiled egg, and you think about it in relation to the Earth, you can think of the core of the Earth as like the yolk of a hard-boiled egg. The mantle is the white of the egg, and the crust of the Earth is the shell of the egg. It's rigid, it's very thin, and it's very brittle. So because the crust is so thin, it basically does whatever the mantle tells it to do. And so here, where the mantle material is being dragged to the left, the crust is along for the ride. So the crust also moves to the left. And here, for example, where the crust is drifting to the right, where the mantle is drifting to the right, the crust is also drifting to the right. So you'll have patterns like this emerge on the surface. And this is stuff that is measurable and observable. It's certainly a heck of a lot harder to observe what's going on in the Earth's interior, and a whole lot easier to measure where plates are moving on the surface of the Earth using GPS. So if you look, the crust is going to be is interacting with itself in a couple places here. So if you look, here's an area of the crust where it's moving to the left or to the right, and here's an area where it's moving to the left. So what happens is that the crust of the Earth, which we said is broken into plates, will interact with, those plates interact at what are called plate boundaries. And you can see I've circled, whoops, no, I'm good, escape. Sorry, technical difficulty. So I've circled all the areas where the plates are interacting with each other. So here you can see that the plates are moving together. So one of the things that we're going to learn is that is called, I wish I had something else to do this right now. That is called a Convergent boundary, where the plates are colliding or converging together. Here, you notice it's something different. Here you see the plates are moving apart from each other. That is something we're going to learn in our next section, is called a divergent boundary. And I promise that you'll see this all typed out so you don't have to just rely on my scribble on the screen here. So diverging means moving away from one another. We move down to the next plate boundary here. You can see again that they're moving towards one another. That's converging. I'm just going to abbreviate it C here. And then once again here, that's diverging. So the part that's cool about this is that by measuring what's going on the surface of the Earth, we can infer what's going on throughout the mantle of the Earth. So your next activity is going to ask you to look at some mantle convection and figure out you can predict will happen on the surface. And then conversely, you'll look at some surface data and infer what's going on in the mantle. So this is just one way that geologists learn about the interior of the Earth.